basically, I'm going to talk a bit about access management, third-party risk management, how are they intertwined, how are interconnected, and how are we making sure that basically all of the areas in blue here are well protected, and especially keep the drinking water safe from adversaries of different kinds. So basically, the water group, any customers of the water group here? Clients? Okay, yeah. Okay, good. So you know a bit on more how we work and why you pay your bills. So it's a drinking water company. As you can see, historically, different regions, a bit all over Flanders, just legacy. So our geographical environment is not really interconnected. We need to connect to other environments, then connect to our own again. It's not always the easiest solution. So about 3.3 million customers in 177 cities and about 1,650 FTEs. I'm focusing mostly on the drinking water part, not on the wastewater treatments, because drinking water was a part of the NIS 1. As you can see here, we were appointed as provider of essential services, NIS directive in February, and we were also established as a critical infrastructure. That's mostly the Ministry of Internal Affairs, and both of these are a federal matter. You know, Belgium is complex, federal and regional level, so these are national legislation. But then again, water and water treatment is all on a more regional level. So our entities or reporting lines are a bit all over the place. So, regional matter. So, what did we do? We established a common working group, a bit like an ISAC, with all the different organizations in the drinking water sector. So we have Waterlink, PITPA, VARIS, Aquadeun, AXO, for Knokke Heist, and all of these six together, they give water to the entire region of Flanders. Then, of course, for Brussels, you got Vivaqua, SWD, and others in Wallonia. We also got contacts with them, but from a legislation point of view, a bit less. So, some intro. Now, basically, what is it we do? It's very easy. It's from source to tap. So whatever source there is, drinking water, ground, surface water, up to the faucet in your house, that's what we try to deliver. So some of them are quite big installations, Blankaart, De Kluizen, so surface water, and there's also some wells deeper, up to 200 meters in the earth. We collect it, clean it, and deliver it. So evidently this is steered by OT, by operational technology. It's our big tanks, big water factories, spread a bit all over the area. In total, around 280 pieces of infrastructure. Water towers, cleaning, reservoirs, pumps to make sure that it gets spread. So first thing under the NIS was, okay, let's establish our risks. What are the main things we need to focus on? And how can we identify risk and set priorities? So that's the first in the risk response and results. So, like any good security officer, I wanted to do it on different levels. And one common strategy is people, process, and technology. So people, the organization, the people, the operators, but also HR, marketing, all of the departments. Then processes. I'm not talking about the physical processes, but really organizational processes. Well, how do we buy things? How do you do quality control? And also technology, that's where the OT comes in. Okay, how do we implement? How do we do change management? How do we vet? How do we take sampling, and quality control of the water? So really the more technical aspect with the laboratory and the seats. So all of these were assessed, and we found a couple of priorities. So for people, the governance was not really clear. There was no steering committee. So we organized a security steering committee with a lot of the stakeholders. And training and awareness general to at least let the colleagues know, like security is important, or it's one of the topics you should think about, just like safety, environment, and other topics. Processes. The main important process was incident management. We can do a lot of effort on a lot of processes, but we can be certain that something goes wrong, and we need to be ready when it goes wrong. So incident management, business continuity, disaster recovery were one of the first things to handle. That we need to be able to mobilize and scale up to very high levels in order to provide everyone of clean and healthy drinking water. And then technology, probably the reason why many people are here, is What is the issue? Access management. People from the coast could access plants in Limburg or vice versa. That's not ideal. So the redundancy on some topics was not enough. There were a couple of single points of failure that could put a region without water or without monitoring or without quality control or something. So it's a big risk in a service you expect to be safe and secure. And another one was the site isolation and being able to work on its own for an amount of time was not really well defined. Because in a worst case scenario, I think of major terrorist attacks or a war, probably large parts of the infrastructure need to function, just like it happens in Ukraine right now, for a long period of time. So we need to be able to isolate sites and really continue to work for days, weeks, or even months. So all of these were inputs for the assessment. So these were also the actions we took. So, as we said, some of the lack of awareness of identity. What I mean with identity is a process identity. There's a certain process in the OT environments. For example, filtering water consists of several components, but it's one logical step in a process. Yeah, we need to give it a certain identity and make sure that this identity performs and behaves how we expect it to behave. So that's one thing. And the access rights and monitoring of these identities, how do we do it? Well, we didn't have an idea yet, but it was a big risk. If we don't know if a certain process block could be abused, there might be an intrusion, that might be open to either data exfiltration or others. Lack of segmentation, well, you could log in from the coast into Limburg, not good. And several suppliers having access to certain parts of the infrastructures on a rather direct way, instead of a centralized gateway where we could check them. So we got our third parties on a critical infrastructure. You don't want to give them access via backdoor, via local site-to-site VPN. And that's where we started to come up with some answers to these issues. So one of the main answers was really introduce very stringent access management for people physically, but also for logical systems, for computers, for digital identities. Making sure that we could confine them, they can only have the access rights they need and can only perform them when needed. It's one way to really secure and make sure that there cannot be any abuse of the systems. Then the risks presented due to lack of segmentation. Well, that's an easy solution. Well, segment it first geographically, then locally, and within the local segmentation, well, logically. Well, you create VLANs or whatever kind of local infrastructure, physically or others. And a third one was working with our suppliers in a better manner. Having better ways to interact with them, making them a bit more listen to what we need to do. So we put out some contractual clauses, minimal requirements, and others. If there are any organizations here that now are or will be offering services, you will be confronted with this. So we also scan technically our suppliers. Okay, what's their infrastructure like? Are there vulnerabilities? Are there things they need to know that could affect us? For example, in an API connection, bidirectional, well, we scan their gateways as well. If we see vulnerability, we notify them and say, please fix your infrastructure. Now it's possible due to the new legislation, we can perform tests, we can perform assessments of whatever organization in Belgium. And then revamp the access management. So, a couple of tools, which is also useful to make it more concrete, to actually say, okay, we go from this theoretical example to more practice. One thing was, okay, all the more contractual, the more document type of controls we put in a tool, or we bought a platform called CU. The CU platform offers a lot of options. We can send questionnaires, we can send documents with suppliers. We give them an evaluation. For example, I've given our own evaluation that we did recently. So we got a security rating of B-. Not bad, can be better, we're working on it. A lot of suppliers are between F and C. So if I take a look at the larger population, we're not doing a bad job. We also got questionnaires that we send out. Okay, for smaller projects, small questionnaires. For larger ones, to make sure that the suppliers understand the importance of cybersecurity, especially in critical environments. And in the end, it also provides insight, risks. It says, okay, look, you've got a couple of vulnerabilities, you've got a couple of issues to deal with, and this was now a recent view on our own risks. So as you can see, there were a couple of critical ones, which we're handling. The high ones all solved, and the medium ones, they have a bit of a longer lifetime, and there's also more because patches don't come up as frequently. It also helps to keep your environment clean and make sure that the people or the companies that depend on us also know that we're in a good shape. Second reason is that it's also very good for your ISO certification or compliance with the NIST directive, so what we did. Now, supply chain management is more the document part, the procurement part. Then we can go on to the real access management part. Now, when starting this, we had we had a lot of questions. How do we do this in an OT environment? You just can't put in a domain and then put in antivirus and put in whatever controls you want, like in an IT environment. So it came clear that there was, when we were assessing all the different use cases of all the different accesses that people needed, of the operators, the electricians, the people on site support, remote support, there was actually very little difference in how critical they were. Almost all of them connected to something that was potentially critical. So we quickly came to the conclusion, we don't do access management anymore, we only do privileged access management. So all of the accesses go via central gateway and via privileged access management. Why? We got 280 sites. Not all of them are staffed. 10, 15 are staffed. All of the other ones are unstaffed sites. We need to be able to manage them remotely. So again, a need. All of these sites are critical because whatever you do, you could really easily put them down, power down, or give a wrong instruction to a PLC. So the remote access is a must. Again, a driver for PAM. So was there really any need to offer different entryways? No. We just used PAM and nothing more. Okay. Once we came to this conclusion, it was time to flesh it out a bit more. So there's basically you've got the IT landscape, the DMZ, the OT landscape, with the typical environment you have. And then how do you go from either IT to OT, from OT to OT, or from outside to OT? Those are the three main use cases we wanted to support. All of them are supported within the solution. So internal, external employees and suppliers, all of them can handle it. Making sure it's one pane of glass for all the access management where you can really configure it and really demonstrate compliance. But also in our modeling of the architecture, of the flows of the solution, we took into account like really Purdue model, Purdue levels, but also took a look at the ISA 112. So it's a bit more elaborate. It's got like 13 or 14 levels instead of 5. But we also try to map these into our architectures. Then a second part, and it's more network related, is we also try to link it to all of the different operational processes, support processes, management processes, operational processes, safety and compliance processes. All of these were also segregated in different VLANs. That's what you see here. That's these. So camera, batching, physical security, fire safety, all of these had their own accesses, their own suppliers, whatever. All of these exist in these remote sites, all need to be managed. So all of these can be handled using one interface or one pane. Also, what if the solution doesn't work? We need to have a kind of continuity plans, and preferably on several levels if it fails. Not just have one option and say, okay, we just go locally to the site and fix it there. It's impossible with the amount of staff and the number of sites if it fails. So we needed to think of different levels of failure modes. So one use case, remote engineering, whether it's programming, it's manipulating things, is this. So it's a very common use case. An OT engineer goes via VPN to our Bastion hosts and can then access, for example, engineering station using Modbus, or you go via Profinet or whatever protocols you want or need. We've got a kind of gateway server, and behind this we got an entire server pool. One that's a jump server, one is TIA Portal, one is WinCC version X or Y. So all of these servers or management servers are available after the PAM. And from these management servers, you can then do another hop to the certain location you want or perform the action or task you want. What do we do with the identities? Because evidently, this getting access to this is a bit risky. So we need to be really certain on, is this really the user we have that logs in here? So for this, there are 3 levels of authentication. The first one is for the user at their own environment. It needs to be known there, and it's their access management. So we can federate, we can trust them, especially larger companies that have a mature way of security. Fine, you manage your users. If you block them, user cannot have any access anymore. Secondly is here. Those users need to have a certain use case and be able to log on. They just can't log on whenever they want or need to. They need a certain use case. So the second level is here. And the third level is here. Here, all the users also need to exist, and we still need to create them manually to know, okay, this contract goes from then to then. We will create accounts for all of the people that give support to programming or whatever, and only give access to the certain objects they really need, whether it be RTU, PLC, or whatever, SCADA. So at least all of the three need to be in order for an access to work, which means that if we want to cut it, we can cut it. If the supplier wants to cut it, they can cut it. If it's not the right time frame, there will not be no access. So meaning it's quite boxed in. And besides, there are a lot of capabilities here to do live monitoring. You can watch the session, what the user is doing. You can cut sessions. You can work together on a session. There's a lot of, for training and awareness purposes, for example, very useful for handing over information. Very good. So that's one use case. Also note that the OT engineer internally can also hop from one site to another. So even if the internet is down, we can go from any site of ours to another site of ours. So the internet connectivity or MPLS backbone or whatever, there are backup solutions. And case 3 is the supplier. Well, then it's a bit more elaborate. The first one was really a person that has our account. Now it's really a supplier that sits somewhere, I don't know, in a SOC or a data center or something, and they need to have access. Well, here again, we have got an additional layer here, the external DMZ. Where the first one is just user can enter via VPN. Now he really needs to access via the access manager, a bastion host on the internet, where a lot of extra security controls are added. It's basically a secure server. There's antivirus. There's a lot of MFA additionally here, more for really the really third parties. And again, this remains basically the same, meaning that a lot of different use cases are present. This all assumes that most of the internet connectivity and network connectivity works, but also that it can fail. The software can fail, infrastructure, hardware, whatever. It's not perfect. So that's why we got a lot. Okay, this becomes very detailed, but I will go through it step by step. There's a couple of layers of DRP or business continuity that we have implemented. So first off, you got the basic use cases. User of the internet can, through all the things, go to our OT cells. Standard cases. Now, imagine there's a big issue. The POM here, the POM solution here, or the access gateway doesn't work. What we can do, we also can log in into the MPLS network directly, either from Proximus or Telnet, and we have routes, and that's a direct access via the network. It's not for everyone, evidently. It's a very glass way to still manage things and to operate things. It's not for third parties. It's really key stuff within the watergroep. We've got a very good way to continue working as usual. Second way of DRP is from one site to another. If the MPLS still works, we can go from one site to another site just within the OT network. It's basically the same. This is really from, for example, people working from home or working from site, they all use the same network connectivity. So two cases of the first layer of DRP. Then there's a second layer of DRP. We still can we have local switches with local ports, local networks. We can still log into the local networks. This already means you need to go on site, but on site we can still plug in dedicated 4G routers, for example, and restore or create direct connections between sites using M2M cards, 4G, 5G, etc. This will not work for every site. Some sites are too remote or are not important. But again, the critical part, it's perfectly feasible to do this. Lastly, if MPLS, if internet, if everything is down, 4G, mobile, whatever, we can still use the local networks to continue working. And in case there are even local issues, then the last option is to locally plug in on the PLCs, but then we will have a lot of work on a lot of installations. So that's our last level of this continuity or recovery. But all in all, it provides a lot of resilience when a certain component breaks. And it's really important for a very critical service that should not be interrupted. So this is our continuing part. So how did we implement this? Because it's nice in theory. It looks nice, the architecture. OK, it seems to work. But how do you go from as is into the to be? Well, about 280, 290 sites. Without service interruption, you can't do it just in a month. There's no way to do it. So it's a program that spends about 2 years. Where we do side by side, we migrate, we reroute even the physical pumping of the water to do so. Also, all the changes that we're doing for security are segmented. First thing we did, network segmentation. Make sure that the network is segmented and still can keep talking. Then we know at least we're a little bit more secure. Firewalls are installed. We have some certain detection. We can do some response. OK. Secondly is the layer of the PAM, the access management. Now, the local sites are secure. Now, the access to the sites are secure. Makes sense? Access between sites. Then we're going to do some steps up. We're going to do network detection and response. We take all the network from traffic from the span ports, from all of these sites. We aggregate it. We add some more in-depth threat intelligence, threat models, Yara rules, whatever technical things you need. You put it in these tools and can actually start hunting. You've got a better asset inventory. And that's the phase we're now. We're now at phase 3. And now we get very interesting results. So now suddenly we saw a result, an alert. Somebody's programming at 11 at night. That was something we didn't know before. It was perhaps the day after we saw it. Now we actually could see, OK, program block X has changed, a stop has been introduced, all of these in an alert. That's really powerful, especially for the OT people and the operations people. Day after, they investigated it, called a colleague, and OK, it was something he was doing during the day, and he finished it. Shouldn't have done it after hours, but OK. But now all of these instances, all of these incidents, now come rise above, and we can now investigate them and see operationally, are there any issues or any security issues? But also for operational incidents, they now have a lot of additional tools and features to actually help with the operations. So sometimes in an OT environment, people are not very keen on security because it might impede their way of working, might add more complexity. But here, due to the native complexity of the environment, especially the PAM is a big simplification, and people are really fond of the program, and they want to speed it up. To have their sites also in one pane, instead of having one laptop with 2 consoles, then another console, and a local one that's still some legacy that's implemented. So yeah. And the last wave, security is also physical, especially for critical infrastructure. We need to report on it. If somebody breaks in and enters, we always need to investigate. Could there be poisoning of water? Could there be something else? What was going on? So also the physical security is being done. So cameras, badges, so whatever, drones, patrols are needed. So that's part of the big compliance. So these slides were made some time ago. So our 13 critical sites, that's 70% of all the drinking water in Flanders, they are done. Now in the meantime, we're at around 40 sites and about 30 remaining. So the program is really well done. Those are the drinking water supply sites. All the rest is basically done because they are very easy and simple sites. It's a water tower, one PLC, one HMI. So from an infrastructure point of view, it's very easy. It's the bigger facilities that pose some issues. But normally near the end of the year, we will be completely done and we will be completely compliant with NIS 1, starting NIS 2. So what are the results? The OT colleagues are rather happy, which makes me happy, of course. Yeah. Then there's more information operational activities. There's an asset register. We know what configuration, what I/O slots are used, what is connected to certain slots, what protocols are used. We know when there's rogue devices on the network. So all of them are very happy with this extra information. In our case, it provides an easier way of working. Instead of using 2 laptops and a local WinCC server, they just have one pane, just access whatever they need whenever they need. And it's now a documented and stable and scalable architecture. Imagine we have 5 more sites. We want to digitize some sites. Well, we got our architecture. We've got our framework. So we just onboard the sites, and we can just move on. So that's why it's a nice story to tell. largely because management was very supportive of all these things. They understand and appreciate that we're a critical infrastructure, and that security and providing the service to the population is their key reason of existence. So that was basically, in a nutshell, the access management.